have here is kind of the general flow of how software engineers solve hard coding problems. So they get an issue, which could be just some set of requirements, and then they look at documentation, examples, guides. They get peer direction to produce code that ultimately gets committed to a Git repository. So something like a Spring Boot microservice, for example. We go through continuous integration for all kinds of automated checks, and we deploy to an environment, in this case, Kubernetes. What we've done is designed a bot that solves hard coding problems in a very similar way. We lean on the large language model to generate code, but we feed it a lot of context about how we would like that code to go. So it follows something very similar, and we construct a guidance system for it, which is comprised of very similar things to this, and then the process continues as it goes. One can imagine a world looking something like this that uses this technology. So you have kind of senior engineers that are responsible for maintaining reference architecture, design patterns, and reference implementations. They create and maintain those. And then junior engineers study them to be able to apply them. You get requirements into the pipeline. The robot uses this reference set to inform its output and then commits code. The junior mid-level engineer reviews the code. During code review, if there are any automated test failures, the robot can attempt to fix those and update commits. It will explain itself in the merger PR about what it's doing. Junior mid-level engineer can always override this flow if necessary to add additional commits. And then they can provide natural language feedback to the robot to also make adjustments to the code. And it will generate that and commit automatically. One of the key things about this flow is that bringing a large language model presents risks to enterprises and organizations. So there's a few key things. We can leverage sort of the existing CI/CD systems that we've built over the years to mitigate the risks of just crappy software development. So we have these automated backstops of security scanning, compliance scanning, secret detection, code quality, all these things that we use in the enterprise to help ensure that the best, safest code gets to production as possible. And the final part of this process is having your senior and lead engineers review this code at this level after it's passed through this generation and filter. And then only if they approve it does it get merged. This is kind of like a standard regulatory compliant pipeline. I think this is highly compelling, whether it's in enterprise or a consulting firm is applying this to develop software for an enterprise.